Hello there. This is a quick informal LaTeX video guide from the content team of EEC16A Fall 2022 from CSM about how to use LaTeX, from your video instructor here who has only used LaTeX for about 4 months. Now, I know you have a lot of questions revolving around this new notion of technology called LaTeX. The questions I received about learning LaTeX are as follows in the video and will be answered throughout the tutorial playlist of the videos. Most important question of all, however, that we must answer in the beginning of this tutorial is, who asked? More specifically, who asked for this unedited video and why am I writing a LaTeX tutorial script on Christmas? Well, this lecture-style recording is an attempt to bring you through the basics and helpful features of basic writing in LaTeX to aid the newer content mentors entering our content teams, and also to help those who just got into a math course like ComSci 70, where LaTeX might offer great help as a skill of note-taking and assignment writing. And more importantly, this video is attempting to serve as a good facilitation for onboarding procedures about content creation. Let me preface the tutorial with the general flow of topics that we should go through. We will first go through what is LaTeX and why would we use LaTeX, and then we'll talk about how to set up LaTeX on your devices so you can write LaTeX on your devices. And then we'll talk about basic writing skills in LaTeX, and finally go over some mathematical concepts in LaTeX that we can use to describe or to write for different subfields of mathematics. So that being said, let's get started with what is LaTeX and why will we use LaTeX. Best way to find out what is LaTeX is by Googling it, and we can then immediately see a Wikipedia page saying that LaTeX is a software system for document preparation. The software system part, we'll talk about it later. When writing, the writer uses plain text as opposed to the formatted text found in WYSIWYG word processors, like Microsoft Word, which we'll also compare later as a substitute product of LaTeX. But before discussing all of these Wikipedia nonsense and translating them into human language, I'd like to first go off a tangential topic and talk about websites. Generally, the websites you see on the internet are in fact a series of files, and there is often a file that notates the contents and the structure of your webpage content, which is often called a HTML file. As you can see, it is written in HTML, a language. It translates the symbols you write on the right side of the screen into the webpage content on the left side of the screen. This type of language that marks the structure and content of a more complicated file is called a markup language. And the action of converting a markup language, like HTML, into its yield, like a website, is called compiling. So just like how web pages are written in HTML to provide a structure and list of contents for these web contents, mathematical text can also be programmatically organized into a markup language. A popular choice of markup language for mathematical text happens to be LaTeX, which is pronounced as LaTeX. I would in fact highly encourage you to use LaTeX as the main pronunciation, just so you don't make the same mistake as me when I'm trying to search up LaTeX in Google Images. Please do not do that. Now, let me show you a couple of example contents that use LaTeX to build sophisticated mathematical text, starting from my own few examples. So here is my own ComSci 70 notes that I organized myself via LaTeX, which, as you see, LaTeX is incredibly convenient for generating well-formatted notes and books, while taking some subfiles like these, which are typesetted files, to show you the contents of a mathematical chapter. You can see the general comparison of LaTeX files and its PDF be something like this. Alright, so let's compare handwriting with LaTeX writing, because if we're using LaTeX, it must have something better than handwriting, or else we would have just settled with handwriting. So let's also think about handwriting mathematical notes, which I will show mine for example again. So this is my notes during EEC16B. As you can see, handwriting all of these things takes quite a bit of time. And it also takes practice to make your handwriting look readable. For example, mine looks absolutely unreadable compared to my LaTeX notes. And handwriting is also not easily editable like LaTeX, where in LaTeX files you can just use a keyboard to edit the contents of your files, which is quite simple. More importantly, CSM contents are supposed to be typed or typesetted printed worksheets, which the handwriting method of creating mathematical text is not quite compatible with. Well, now we know that handwriting doesn't work, but what if we use Microsoft Word to write mathematical text instead of LaTeX? Great question. As a former Microsoft Word user, let me tell you why I converted to LaTeX then. First of all, when writing sizable documents or books like this note, which, as you will see in a bit, takes quite a bit of space to write for, Microsoft Word documents of similar sizes, such as this, which is around 35,000 words, becomes incredibly large to store and also causes the overall editing process in Microsoft Word to be very laggy. This is unfriendly to both the hardware memory, your computer, and your sanity. On the other hand, LaTeX files are fairly space-conserving and performs at least as well as Microsoft Word can do when it comes to writing scientific documents. The same holds against Google Docs and Notepad and other text editors as well. Second of all, LaTeX has a lot of supported libraries for domain-specific markings. So, for example, you can simply see some good LaTeX libraries that support chemistry. For example, here is a simple tutorial about chemistry structures and molecular structures, which you can easily annotate, compared to in Microsoft Word, where we basically have no chemistry support. So scientists would greatly benefit from typesetting in LaTeX because text editors like Microsoft Word doesn't offer these science domain-specific notations. Following along that point, if you want to type mathematical equations in Microsoft Word, as well as type Unicode mathematical symbols, you'll have to go through a lot of mouse clicks and a lot of memorization. For example, if I want to write an equation, I'll have to go to the insert here, or maybe I can just press the easy key, but then I'll also have to go through a ton of different weird symbols to type up the equation I want to use. So it is incredibly efficient to use LaTeX in place of Microsoft Word's math equation system. Now, granted, Microsoft Word is a general text editor and is not meant to specifically write mathematical documents, but so if you're writing an essay, it would be wiser to use Microsoft Word instead of LaTeX. But since we're writing scientific documents in CSM, we'll probably like to leave it to specialized versions of Microsoft Word, which in this case can just be LaTeX, the markup language. So now that we have discussed the motivation of learning LaTeX and what really is LaTeX, now let's talk about how to use LaTeX. Well, pretty simple search. But, well, let's talk about it as well. Since LaTeX is a markup language, we would also need text editors to write LaTeX documents, just like how you need IDEs to edit programming language files like Python files, which is why I have VS Code helping me write LaTeX. We'll talk about that option later. Well, the two editors I tried LaTeXing in so far, throughout my experience of using LaTeX, happen to be perhaps the two of the most popular methods of typesetting in LaTeX, which will be doing it online or doing it offline. If you decide to use LaTeX online, here is a fairly convenient LaTeX editor that I'd like to show you called Overleaf, which I'll just search up here and lead you to it. So when you type up Overleaf, you might not immediately come up to this page. What you would need to do, which I'll demonstrate in the incognito tab, is that first you go to overleaf.com and then you try to log in. Well, you might ask, if you don't have any account, how do you log in? Very fortunately, UC Berkeley already has these Overleaf accounts prepared for you, so you just need to type in your Berkeley address email and log into it. And then you'll be able to access Overleaf on the premium plan. Pretty nice. So, to start up a new LaTeX document in Overleaf, what we can do is click New Project. And then, depending on what kind of project you want, you can just choose the different templates, but for demonstrative purposes, I'll use a blank project here. We can also name our project, which I'll, in this case, just say CSM16A LaTeX tutorial doc. I'll try to share the link of the document at the end of the section. Now, before we move on to learn about how to write LaTeX in this seemingly simple interface of a text editor, let me also introduce you to my current alternative of LaTeX writing, which is the local option of writing LaTeX offline. You will probably not use this option in CSM because your content team most likely use Overleaf, which is this option that is an online collaborative platform, meaning your entire content team works on one larger LaTeX project in a larger code base. For example, there will be a couple more files here, which you and your colleagues will work on together just like in Google Doc or in VS Code LiveShare. I will show a part of Eek16a's code base later for orientation for Eek16a's new content team. And if you happen to use the local option of writing VS Code, it will be very difficult for you to participate in the Overleaf efforts from your teammates, which is why I would suggest you learn Overleaf first before heading off into using VS Code for LaTeX. So then, why do I use LaTeX locally while being a content mentor? Well, the good thing about typesetting LaTeX locally is that you can type LaTeX offline, which will be incredibly useful in environments where the internet does not exist. For example, on an airplane, in an outdoor cafe, or in any UC Berkeley library of your choice that uses Eduroamster Wi-Fi network. On the other hand, I just really like being able to reduce the number of platforms I use for work, so work-related items become easier to manage. This is just personal philosophy, at the cost of overtaxing my computer's hardware memory. However, typesetting LaTeX locally comes with another disadvantage, which is that it takes some patience to set it up in VS Code. So here is a VS Code tutorial document that I like to use when trying to set it up with LaTeX. And in VS Code, we have this famous LaTeX extension called LaTeX Workshop by James Yu, which a lot of my colleagues use. So there are a couple more guides to reference. For example, I also reference some Chinese guides for some reason, and I don't really understand why I did that. But just in case you happen to like reading Chinese guides, here's the keyword I used. And you can see a lot of different guides that teach you how to use LaTeX on VS Code. So there will also be some different guides where it uses a different language, or it asks you to download LaTeX from a non-official source. Please download LaTeX from an official source. Alright, last but not least, let's discuss the last few items about locally typesetting LaTeX, which is the user experience. So how does typesetting LaTeX in local feel like? To be honest, it feels exactly like how you would do in Overleaf, except you can do some customization here. And it's also incredibly simpler to organize your files on a local system rather than on an online system, which we'll see later when we deal with a larger code base of LaTeX files. But generally, personally, I prefer using local editing for VS Code just because VS Code has a better user interface. And once again, unfortunately, CSM doesn't really have the leisure to deal with VS Code since VS Code's LiveShare function is not as well implemented as the Overleaf online collaborative function here. So we'll still be using Overleaf for the tutorial video. And once again, the experience of typesetting in Overleaf is extremely similar to that of VS Code, so you can feel free to learn the Overleaf version, and you'll still be able to learn the VS Code option once you manage to set it up on VS Code. Alright, now let's talk about the general template of LaTeX documents, which, as you can see here. On the first line of the LaTeX document, you see the line \document class article, which notates the type of document you are typesetting. There exists other formats outside article. For example, the CS70 notes you see in VS Code previously uses a format called book. But article is the general category of documents that we work with in CSM in most of the articles, or most of the LaTeX documents. So for example, let's hit Control S or Control Enter to compile the documents here, which we'll then see on the right-hand side of the screen that we have a PDF document compiled for us. And if you click the download PDF here, it will then download a PDF version of the document you see here, which is compiled into this kind of file. It's currently one page so far, but we'll make it longer later. We can also add additional parameters here to demonstrate the parameters or copyright of your document. For example, here are title, author, and date, which you can then compile to make the title section of your document. More importantly, even the document class here can be added with additional parameters to show different properties of the document. But in this case, additional parameters don't always take this \command-like structure. Some commands themselves take on additional parameters using brackets. For example, if I would like to limit the font of my document, I can type 12pt here, which is now in the right input. And I can also type a paper size to limit the size of my document. So let's see how the difference fares between a 12-point letter paper and this original document. As you can see, the general size of the document increases, and the paper margin, while invisible, does decrease a little bit here. Generally, each course has a different way of formatting their document, so all of these 6 lines above are managed by your course automatically in different files, which we call style. Let's move on. On the second line of the document, you can see a line called use package here, which is essentially the Python equivalent of import when you're trying to use different LaTeX libraries. LaTeX is also well supported with different libraries that help you type different mathematical symbols, which we'll come across later. So in this case, UTF-8 is the additional parameter we're using for the package here, as it is put in brackets. And input inc here is the name of the library that we're trying to input to support encoding of some characters. Now you see we also have several other parameters of the document to play around, which we talked about before. For example, changing the author here, which doxes me, as my YouTube channel does, to some different name. We'll change the title of the document. As you can see here, my name is now replaced to August. To compile these elements, and we can use the command make title here to make the title comment show here. For example, if I remove the make title here and compile the document, I'll only see the section part here. Well, very fortunately, we don't really need the title section here, so we'll just delete the make title section forever. Last but not least, to add a comment in the LaTeX file, you can use a % mark. For example, let me show you how to comment in the LaTeX file. I can type up a LaTeX comment using % marks and say this is a comment. While I can also not use a % mark and just directly write here, this is not a comment. And when I compile the document, I'll see that the comment line doesn't show up, but the not comment line shows up. And now let's go over some Overleaf basic functions, since we're also using Overleaf as our LaTeX editor. But right before that, let me teach you one more thing. To use the % mark directly, without having to make it into a comment notation, what you can do is use backslash before it. And this backslash is an escape character, just like you see in most of the programming languages. So backslash %, for example, will directly give you the mark %. All right, now let's go back to what we can do in Overleaf. So if you click on the menu tab here, which I did, you will see a lot of different options here to play with. Let's go over some other basic things first. So for example, you can see here that I expanded a file tree where here I can upload different documents, and I'll play around the menu option as I add new documents to this series of documents. So once again, this is called a LaTeX project, meaning that it contains multiple files in one overall project file. For example, I can also add a different .tex file, such as not.main.tex, and this will give me a separate file that is empty. We'll discuss why we would like different files to exist in one single project later, but for now, let's look at how having different files can influence the overall structure of a project. So I'll copy paste the contents here and replace this line with this is not main document. And I'll press compile on the not main document instead using, once again, Ctrl S or Ctrl Enter, depends on your choice. You will then see that the text changed to this is not main document. But if I switch back to main, the text switches back to this is not a comment, or this is a main document, not a comment. So you can see that pressing compile on a different document does bring us different PDF that we can download. It is notable that the PDF file name will still be the same. We can also have a third file, which, for example, this one I'm just going to call not work. And in this not work file, what I'm going to do is to not write the begin end document thing, which we're supposed to have to enclose our document contents. So for example, I'll just say not work. And I'll try to compile on this not work.tex file, which doesn't give me not work. The reason why is because when Overleaf encounters a file that it cannot compile, what it does is it then goes back to the main document and compiles the main document, which in this case is called main.tex, which is why you see the main document content showing up here. If I switch this to not main.tech, I'll get this is not main document, because not main is the main document. What if I switch it to this not work document here, which is not supposed to be compiled? Then I get a no PDF error, which means that my PDF just does not work at all. Let's switch this back to main. Okay, so say that we are facing something with 35,000 words here, like previously. It will be much easier to separate the contents of one large file into several subfiles, and then try to insert all of these different files into one single file, which, as you see in Python programming, is also the case, where you don't try to code everything in one single file, but rather you try to code everything in separate files. So here's a useful content for doing that in LaTeX, which is called \input. You can say \input and then put a file name here, and it will help you input the file content from a different LaTeX file, which is quite useful. So that's the \input. Last but not least, you can also see other different options here. You can play around with Overleaf. For example, here's also this editor theme, which you can choose for yourself. And there's also hotkeys, which is pretty convenient. You should probably try to learn some of these, I think. So now let's talk about how to write in LaTeX. In any programming tutorial, the first program we need to learn is Hello World. So let's try to write Hello World here. Alright, so how do we write Hello World in LaTeX? Well, here's how you can produce a piece of LaTeX text that says Hello World. So we're just going to type out Hello World here, which, as you can see, the card here stands for trying to help you generate different Unicode contents. And we're just going to type this out. And once again, we encounter the same file, the same character, and then we'll just keep typing the character. As you can see, these are hexadecimal. Right, and let's try to compile it, which says Hello World here. Nice. Or alternatively, you can just type Hello World. Right, that works out. Okay, so to type any piece of text in LaTeX, you can just directly type the text. These are not necessary. That was a troll. Now, here are some techniques of typing. For example, I can bold a text, which the hotkey for Overleaf should be Ctrl B. Let me try it out here. Right, it works. So this text BF command with a curly bracket here bolds your text that is written in the curly bracket. As you can see, I have a bold here. I also have italicize, which is Ctrl I, which makes your text diagonal. Is that the word? Diagonal. I can also underline my text, which is underline. And I can also emphasize my text, which means bolding and italicizing at the same time. Let's try to compile this and see what happens. Oh, by the way, if you like to complain about the document size here, you can also press Ctrl+ to expand it here, which I find pretty useful when I'm trying to revise my worksheets. So bold, italicize, underline, emphasize. For some reason, emphasize here doesn't bold. It's okay. Maybe it just actually doesn't bold. Okay, and last but not least, if you like to cancel yourself, there's also a way to cancel your text, which comes with a new library called cancel. And the way you can cancel yourself is to write \cancel, and then as before here, you'll put the text you'd like to cancel. As you can see, you have canceled yourself. However, as you can see as well, just changing a line on the text editor doesn't really make us switch a line onto the next paragraph or the next line. So in order to switch to the next line, what we need to do is type a line break, which can either be used as new line, \new line, or just as a double backslash. This would mean that a single backslash by itself should be able to show you a backslash. Right, so as you can see, we have successfully switch new lines. However, just switching new lines is not a good enough robust system for switching lines. Sometimes we'll also have paragraphs where we would like to have some space between the different lines to show the beginning of a new paragraph. In that kind of case, what we can do is type \par to show that we are starting a new paragraph. Also, as you see here, Overleaf has a good function that is autocomplete. Well, this also comes in VS Code because VS Code has IntelliSense and the LaTeX built-in that helps you to autocomplete. But Overleaf is pretty nice for the autocomplete function. Okay, so we can say \par to mark the beginning of the paragraph. And we can use new line to continue off a paragraph. And last but not least, I can also new line and then \par new paragraph after new line. Let's try to compile this and see what happens. Okay, so we can see that par starts a new paragraph by indenting it. The new line begins off, but also does not get indented. Then I start a new line, and then I start a new paragraph, and it gets indented again. That's pretty good. Okay, so this is the basics for writing text in LaTeX. Now let's talk about how to paste images, because in a lot of times your math documents would probably also have like images. Before that, let me talk about a common practice of organizing your images in CSM files as well as in your own personal project. You'll probably like to organize your images in a separate file. For me, I usually call this separate folder for images fix. And let me show you another example of how I organized fix before. So as you can see, I organized pictures in this folder called fix here, which every subfile has a set of images that it contains. So I would really like to continue this convention off in the later content systems so that people can search up images quite easily. Okay, now that we have expressed the sentiment, let's try to insert an image here. Before that, let's also start a new section called insert image here. Okay, so to insert to first of all provide your Overleaf project an image, you can choose to upload an image, which you can select from your computer, but I am not going to show you my computer. So what I'm going to do is use another option called import from another project. So I'm going to select from my previous project some kind of image. Such that I now have this image from a separate project that I can just directly use. Okay, let's try to insert an image here. So first and foremost, the way I would like to insert my image is, let's start with a basic one. So let me just reduce the dimensionality here. And okay, I am going to start off with inserting an image in an uncentered way, which would use a simple command called \include graphics. As you can see, here are optional parameters, which we'll use one of them later. And the curly bracket here will contain the address towards your document. So your current working directory should be where your main document is currently located. In this case, at the root directory. So what I'll do is just type root directory /fix/ and then my file name here, which is symmetric input .png. But another thing with include graphics is that this is actually a command from a different library. So I'll also like to import a library here, which is called graphics. That should enable me to use this command to insert graphics. Let's try it out here. See if it inserts an image. It does. Congrats. So as you can see, this is an uncentered diagram, which I'll use a new line with to keep things simple. And as you can see, here's a circuit, which we all love, I think. Okay, now let's talk about a different way to insert images, which is not necessarily different. It's just using a more formal way of doing so, which is using a thing called figure. To insert a figure, as defined by LaTeX, you can first type begin figure, followed by end figure, and within the space between begin and end, you should type in the contents of your figure. So in this case, figure also comes with a couple of optional parameters, which you can also type in the bracket here. For me, I'll use H, which means here, which means that I'm going to insert the figure here where my text is currently located at. There are other options such as T or P, but you can explore those on your own. So first of all, I like to use \centering so that my entire thing is centered. This is how you center a div in LaTeX, by the way. So then I'll like to use input, which will work. Well, actually, let's still use include graphics here. Okay, and then I'm going to use my formal address of the figure. Okay, here is one of the optional parameters that I found useful, which is scale. You can use scale and then type equal and then type a scale that you would like to scale the image by. For example, if sometimes your picture is too big, you can say scale equals 0.5, which will shrink the area of the picture by half. In this case, the picture is a bit too small, so I'm just going to increase it as scale is equal to 1.5, which means the area is going to be 1.5 times larger than before. We also have captions in figures, which is much more convenient than just inserting it. So for example, the caption of this diagram might be superposition circuit. And I can also have a label of the picture, which is basically the variable name that refers to this figure. I'll just call this fig1. Okay, so now that we have typed this up, let me also show you a couple of neat tricks with what the label can do. I'm going to type a text around here. Begin figure has a weird property, so I'll have to use a new one right here. Okay, so I'll say here a text referring to figure number. So sometimes when writing questions, I like to refer to my previous figure, right? So for example, I might want to refer to this figure by number. But this number might also change if I add a new figure around it. So how I can track my figure number dynamically is then say \ref and then put in the label of the thing here, for example, fig1. Okay, let's see what happens here. Okay, so first of all, you do see that this entire thing becomes larger. This is not centered because the picture itself is left aligned. You can see figure 1, the caption showing here. The label doesn't show, but you can see that the reference here corresponds to the number 1, which is the number of the figure. Now let's see how this changes when we post a new figure here. As you can see, now it refers to figure number 2, which is because this figure that's labeled fig1 is in fact the second figure of our document. Alright, let's go back to the original so that it's not so confusing. Okay, other than pictures, sometimes we can also typeset these kind of circuits things as LaTeX files. So for example, I'm going to upload another example here from my previous project, which would be a CS70 graph. How exciting. So this file is called example.tech, and as you can see, it is a LaTeX file. It is a series of LaTeX comments here that represents something you'll see later. To input something like this, what I can do is directly use \input. But before that, let me also add one more library so that we can use the example document there, which is called TIX. General graphics library that you can use for LaTeX. Okay, now let's try to input a diagram here. We can either directly input a diagram as before, which is as follows. I can try to center this using begin center and end center and put the thing between begin center and end center. As you can see, this is kind of like how a HTML tag works. For example, when you're trying to center something, you'll probably put it in a center, in between center tags in an HTML file. In this case, you put it between begin and end. This highly demonstrates the similarity as a markup language between LaTeX and HTML. Coming back to directly inputting a diagram, we can use the \input. And I'll once again type in the address manually, or you can just copy paste. In this case, it's not too difficult, so I'll just do this. Okay. So as you can see, I have successfully inputted a diagram that shows the concept of duality in comp size 70 If that sounds like a riddle to you, don't worry. It also sounds like a riddle to me, despite having taken comp sci 70. But anyways, this is a graph that is directly written in the LaTeX language. Pretty cool. We can also do this with big and figure, as we talked about before. I'll spare the details here. You know what's gonna happen. It's basically replacing include graphics with input. Okay. So that being said, we learned how to insert images, and now let's talk about using lists. So sometimes we would like to use lists in a LaTeX document because it is useful to order things in bullet points. So what I'd like to do then is talk about lists. So LaTeX lists in LaTeX comes in two flavors. One is unordered, and one is ordered. When something is unordered, is like a bullet point where the items you have don't necessarily have an order, and the easier way to type it out is called begin itemized. As you might have guessed, and itemized. And in between, you can launch an item by saying \item and then directly typing the content of your item. For example, I'll say item hello \item world. And let's scroll down a little bit, and you can see bullet points. Now you can also change the alias of this by directly typing bracket and then the mark you want the bullet point to be in. Let me show you a comparison between having typed this and not having typed this. If you do not do anything, the default mark for itemize this bullet point. If you do something for the mark, it shows you the mark for it. Now, what if this becomes increasingly long? If the bullet point mark you choose is too long, it actually extends throughout the page, the left hand side of the page. So if you're trying to use bullet point for something, please keep your bullet point symbol small, like this, which is substantially better. Okay, what about ordered lists? Well, ordered lists are actually very simple. Very similar. It just uses a different keyword instead called enumerate, which, as you can see, the default marking is from numeric 1 to numeric some other number, and you can still customize your bullet point mark here. All right, lists is quite a brief section. We have gone over how to use lists in LaTeX. Let's talk about the most important part of LaTeX now, which is basic mathematical writing, which is about how you write math in LaTeX and you will then see the gracefulness of writing mathematics in LaTeX. So there are two ways to write math in LaTeX. The first way is you can use inline mode, such that the mathematical equations you use will be in line with your text. For example, I'm going to write out a linear equation here. And you can see when I use the inline mode to write the mathematical equation using the $sign here, you will see that the contents of your equation directly show inline, as against using the display mode, which uses a different symbol, that is the bracket thing. And if I type an equation here, what's going to happen is that it's not going to be in line with the text I have here. It's going to be outside the line and centered on its own, as you see here. There's also another way to do this, which is to replace this bracket symbol with $sign. Sorry. Dear God. Okay, hold on a bit. Oh my God. Sorry, this is incredibly difficult to deal with. It is incredibly difficult to deal with this kind of input. Okay, so as you can see, using a $sign does the same thing. But it is generally not recommended to use the $sign anymore. For some reason, Overleaf says this. And personally, I also prefer this way of writing because the bracket looks a ton more aesthetic, I think. Yes, okay. So this is a general way in which you'll write mathematical equations. Well, by far, we have only been using simple expressions like adding, equal, and just typing out variable symbols. What else can we do in equations? Well, we can also write mathematical symbols. So for example, I can write Greek letters, say alpha. And as you can see, the Greek letter alpha shows here, which also shows here in the autocomplete autocomplete function for Overleaf. What if I type it out directly? It will be an error where it says missing $sign inserted. This is because if you're typing a mathematical symbol like a Greek letter, you should always try to enclose it in either a $sign or a bracket such that it is in math mode. So in LaTeX, we switch between text mode and math mode. General writing is in text mode, which means things are treated as plain text. When you're using math mode, or when you're about to use math mode, it's usually when you're trying to write some mathematical expression out, such as these equations. Okay. We can also use parentheses in equations. For example, I'm going to show you something rather complex here. First of all, we can have curly brackets, which are shown as backslash and then curly bracket. The reason why we use backslash here is because we're using escape characters, and the curly bracket here themselves actually already have a meaning, which is why we're using backslash to show the original curly bracket. You can also see a backslash big here, which I'll explain what it does later. For now, just go with the flow. I'm going to write a bit more code to here to show you the thing I'm trying to show. Is that even human language? I'm not sure. Parentheses is normal here. There's not really why, I just wanted to type a normal thing. Okay, and let me show you how to write exponents in this expression as well. To write exponent, you can just say x and then caret, and then the exponent you like. For example, x to the 2, x to the second power. But if your exponent expression is more than one character, you would like to enclose it in parentheses. Let me show you why. Let me show you why later. But for now, I'm just going to finish typing this thing and show you the different changes. Okay, so for a subscript, it's the same thing. If your subscript notation only has one character, feel free to just do this. If not, please use a curly bracket to embrace the statements you have here. To embrace the subscript notation you'd like to say. Okay. Last but not least, I'll write a simple expression here. Okay, so the same logic applies to whatever you're taking to the power 2 when trying to write subscripts or superscripts. Okay, let's see how the equation shows up. So as you can see, we have a rather complicated equation here. The backslash big good and the backslash big are supposed to mean larger brackets and curly brackets. Let me try to change this to capital big and see what happens. Okay, so as you can see, the size of the bracket increases. Meanwhile, you can also see superscripts and subscripts here. And you can also see the general way of writing exponents when the thing that you're trying to take the exponent to has multiple characters. Now let's see what happens if we remove the curly bracket here. It will then only take the first character to be the exponent, and the second character would just be left out, which is why you see x to the 2 and then 3 instead of x to the 23rd power. Same for here. Let's see what happens. As you can see, this is not the original expression we're trying to express, which is why having curly bracket is good. I would, out of habit, also curly brackets whatever I'm taking the exponent to or subscript to. But since these are just one character, I'd rather just not do that. Which is why, as you can see, I also did not put a curly bracket around 7. This is just personal style. And again, the way you type out this series of big equation also depends on your personal style of coding. For me, after going through scheme from CS621A, I would like to stick to this kind of coding style for myself. But just make sure your LaTeX is readable to your colleagues, because if your LaTeX is not quite readable, your colleague might want to spill coffee on your desk. Speaking from personal experience. So, last but not least, here are some useful math environments. Environments in general just mean special places where special rules of writing mathematics apply. For example, the begin itemized here, the itemized thing here is also an environment where the special rule within begin and end itemizes that everything you write is in bullet points. the begin center and end center here is also a useful environment where everything you write in the center in this environment is just going to be centered. Okay, moving on from that, let's go through some quite convenient. What am I going to say? Quite convenient environments. First, let's talk about cases, which is useful for expressing systems of equation as well as piecewise function. For example, let me type a simple section of text here. Okay, so here's the thing. Some of the environments themselves don't have math mode built in. So what I'll do is first write the math mode notation, and then start writing the environment so that I don't have to put $signs around everything. So for example, I'm going to say this weird notation is equal to, and then I can put a cases here to show that this is there's a piecewise equivalence to what the notation might be equal to. For example, this value might be equal to 0 when something happens. All right, I'll explain this whole series of things later. Let me write this out first. This one is comparable to... Okay. So what this entire line means is, let's look at the character by character. First here is 0, which is what this expression is going to equal to, depending on the piecewise condition here. This and sign here is a special character that means align, which means I am going to try to align whatever has the end character as well throughout the different lines. We'll see the effects of align later. Comma is just comma. This backslash text here is how you use plain text mode when you're already in math mode. And then as you can see, this entire text is switched into plain text mode, which is why I use the $sign here again to switch into math mode from a text mode. Okay, let me type out the rest of the expression here to see how this overall thing can show graphically here. The double backslash here is a way to indicate I'm going to into a new line in this cases. Right, let's see how it works out, which it doesn't. And that is because cases uses another different library called AMS Math. As you can see, we have accumulated quite a bit of libraries here, but your course organization system for content will also take care of that later. Let me just recompile this, and as you see, no error. So here we see how the align character works, which is, as you see, the commas are aligned to each other despite their preceding text being of different length. And you can see the cases here showing us a good piecewise expression. Let me also show you how to directly print the code, which I will use the package verbatim here. Another popular choice. 601A uses a separate library called LSD listing, but for demonstration purpose, I'm just going to be sticking with verbatim. And then directly paste this piece of code here and press Ctrl S. So when I compile, you can also see a raw text of code here. Quite useful. Other environments that I like to show, there are about 2 more. One of them is tabular. Tabular just means creating a new table. Which I am too lazy to directly type out, so I'm just going to copy from a modern document. From around here. I see you. And let me directly show you later via graphics how this document looks. Okay, as you can see, tabular here shows you a table, which you can customize the style of by using this kind of syntax, where C stands for one specific column, the space between shows for the separator, and this double bar corresponds to the double vertical boundary you see here between the set of 2 columns. And as you can see, the ampersand symbol here still serves for alignment, and line break still serves for I'm going into the next line. The H line here is the horizontal boundary, which I don't need to connect the line break to. Last but not least, you can also see some different mathematical symbols here. The code is right here, but if you would like to print it out on the document, you can once again use the verbatim. Last but not least is a very useful environment I'd like to show you called align. So what align does is that it shows you a series of equations, but you can align it using the and symbols as talked about, the ampersand symbol as talked about before, and use line break to indicate line change. As you can see, the series of equations are formatted rather beautifully than having to write all of these in display mode. And align is also one of the few environments that bring math mode on its own, while also enabling you to line break and align very freely. Alright, so that's all of the basic LaTeX writing skills that I'd like to show you within the span of, I don't know, an hour already? But here are some closing regards on learning LaTeX. So LaTeX is known to have a rather steep learning curve, but you can learn LaTeX rather simply by practicing a lot, and as well as reading other people's LaTeX, which you can find your CSM's prior work by searching up the GitHub repository of CSM Berkeley, and here they'll show you a couple of different things that your ancestors in CSM has already done. For example, I think the 61A repository is rather updated, where you can see the LaTeX work of CS61A from this src file. I think. Or maybe it's a different file. I think it's called topics instead. Yeah, it's called topics. And if you click into topics, you can see the different LaTeX files that they made for different questions they have. Same for 16A, except the 16A file repository, which we're not responsible for yet, is quite outdated. So in this case, your alternate solution is to ask for access of your Overleaf project repository from your senior content mentor, such that you can access old code from your ancestors in CSM content teams. Last but not least, there's also a couple of good LaTeX tutorials if you'd like to read more. For example, here is a 30-minute version of LaTeX tutorial, which covers most of what we have gone through in the last 30 minutes, that most people are still too lazy to read through regardless, which is why they resorted to this video, I guess. So, summary of resources you can use to learn LaTeX and CSM is Overleaf tutorial and the CSM GitHub repository, as well as just asking your own senior content mentors about how to use LaTeX. If you are not in CSM, you would like to learn about LaTeX, what you can do is search up on Google about LaTeX whenever you have any problems. For example, when I would like to ask about how to make a graph in LaTeX, I can just search up how to write a graph in LaTeX. And I'll find a couple of tutorials helping me on how to write graphs in LaTeX, which honestly is how I learned the most about how to write LaTeX. Alright, so that's a summary of resources that I personally have used when trying to learn LaTeX. The link for these two note documents that we used today in the tutorial will be linked somewhere in the description video, I think. And if you are interested in learning more about LaTeX mathematical symbols, which you probably would need to if you are working in the CSM content team, feel free to visit the tutorial playlist videos that this video is located in. Alright, I guess that's it. Go Bears?